In this video, I'm going to explain what a least common multiple is and how to find them. So a least common multiple, or LCM, is the smallest number that two or more numbers can divide into evenly. So you can think of it this way. If you and your friend are jumping on a trampoline and you both have a favorite number of jumps before you stop to rest, the least common multiple is the first time you both stop jumping at the same time. So, for example, if you like to stop every 4 jumps and your friend stops every 6 jumps, the least common multiple is 12 because after 12 jumps, you'll both be stopping for a rest, right? And we can see this. So, we have 12. Well, 12 is both divisible by 4 and 6. And this is what we're looking for, right? This is the number with the least value that is divisible by both 4 and 6. So, hopefully that makes sense. And another way we could have figured out the least common multiple of 4 and 6, and I'll write some notation here that you'll probably see when dealing with LCMs, is you'll see it written as LCM and then parentheses, the number, comma, the other number, right? Okay, so to figure out the least common multiple of 4 and 6, a simple, straightforward way is to just list out the multiples of both these numbers until we find one that matches, right? So we will list out, let's say, 5 of each. So this will be 4, and I'll write commas here. So 4, 8, 12, 16, and then 20. And we'll do the same thing for 6. So we'll have 6, 12, 18, 24, 30. And we see here the first one that we find that are the same right here is 12, and that's a poor circle, but you get the idea, is 12. So this is a very simple, straightforward way to find the least common multiples, and I'll show you a better way in just a moment. And a better way to find least common multiples is by doing this, and I'll show you. So we will take, and I'll rewrite this, LCM of 4 and 6, right? What we're going to do is list out the prime factorization. And what that means is just breaking up the number into all of its prime numbers. And this is pretty simple. I'll show you. So we have 4. Let's see. What is 4 divisible by? 4 is divisible by 2. So we're going to break it out into a tree-like thing, right? So this is going to be 2. And then 4 divided by 2 is 2. And you'll notice here that 2 is prime numbers, so this is the prime factorization. So the prime factorization of 4 is 2 times 2. And for 6, let's break this down into 2 times 3, right? And 2 and 3 are also prime numbers, so we can't break this down any farther. So 6's prime factorization is 2 times 3. Now, in order to find the least common multiple, we are just going to combine their prime factorizations. But we have to take account that both of these numbers also share some prime numbers, right? So they both share 2's. So we will actually just list out 4 first. This will be 2 times 2. And notice here the 2 is already covered in the 6, so I don't need to worry about that, but there's no 3. So we're going to multiply by 3 as well. And then we'll just multiply this out. So this is 4, and then times 3 is 12. And this is a much simpler method when dealing with larger numbers, right? Because you don't want to list out just a bunch of multiples of giant numbers in order to find the least common multiple. So we do this. Now let's try to find the least common multiple, or LCM, of 8 and 12. And we'll use both methods that I mentioned earlier to find it. So first, let's just list out some multiples. So we'll list out, this time, 5 again, I guess. So 8, 16, 24, let's see, 32, and then 40. And then for 12, that is 12, 24, 36, and we can stop here. We already see that we have a 24 in common here, so the LCM is going to be 24, and I'll go ahead and write equals 24. But let's go ahead and use our other method by breaking these numbers down into their prime factorization. So let me erase a little bit of this down here so that we have more space. And let's break down 8. Let me change colors here. Let's break down 8 and then 12. So 8 can be broken down into 2 times 4, and then 4 can be broken down into 2 times 2. So its prime factorization is 2 times 2 times 2, and then 12 is 3 times 4, right? And then 4, like here, can be broken down into 2 times 2. So this prime factorization is 3 times 2 times 2, and I'll separate those. And now let's go ahead and write the prime factorization of 8 here. 2 times 2 times 2. And we notice here that all these 2's here are covered, but now we need this 3, so we'll go ahead and add that on. So this will be 8 times 3, which is 24, and we get the exact same answer. The least common multiple of 15 and 42. Now notice these are bigger numbers, so at this time it is going to be harder to just list out the multiples. So let's use the prime factorization method only this time. So we'll write out 15. Let's see. 15 is broken down into just 3 and 5, right? And these are both prime numbers. They don't have anything that can be divided by. That wouldn't leave them as a decimal. And then 42, let's see. This would be 6 times 7. And then 6 can be broken down, but 7 cannot. So 6 will be broken down into 2 times 3. So the prime factorization of 15 is 3 times 5, and the prime factorization of 42 is 2 times 3 times 7. And then to find the LCM, let's go ahead and write out the prime factorization of 15, right? 3 times 5. And then, let's see, this 3 is already covered, so we just need to write out times 2 times 7. I'll write this over here, times, 2 times 7. Let's see, so we can go ahead and write 14 times 15, and we can do that multiplication problem, and I'll do that real quick. So this will be 15 times 14, 15 times 14, sorry, and this will be 4 times 5 is 20, so we got to carry the 2, then this is 6, annex a 0 here, and I can go ahead and mark out this 2. This will be 5 and then 1, so this is 210, and that is our answer to the multiplication problem. So our least common multiple for 15 and 42 is 210. And